Well, hello, everyone. This is Cynthia Tomain with Interactive Brokers, and thank you for joining us for today's webinar with Byte Academy, where we'll be going through the Learning Byte series. In today's session, we'll be exploring natural language processing. I'm very pleased to have with us today Kenzo Traveling, who is going to be doing today, or presenting today's webinar. Let me put the information up on our screen, and I'm going to go ahead and pass this now, pass the controls over to Kenzo so that we can get started. Kenzo, thanks for joining us here today, and you now have the presenter controls, so let's take it away.
Cool. So what we have here is my IPython Notebook, exploring natural language processing. And I'm just running IPython from my terminal. If you don't know how to get that started, you can reach out to me at this email address, kenzo.t@byteacademy.co. And the GitHub profile that we'll be working from is just github.com and then / my last name. And inside of there, you can clone the repository from ib-webinar, and these commands will also get you started with the NLTK module and the regular expressions module inside of Python. If you're unfamiliar with some of these, we can either follow up with, say, perhaps another tutorial part of the tutorial series, where we can show you some of the basics of Python and using the Python package manager, which for Python 3 is called pip3. And this last command down here will just get you set up with all the references that you'll need for the NLTK module that I mentioned earlier. I'll also be posting this nltk.zip, which will save you a little bit of time if your network connectivity this is a little spotty, and that'll save you from some of the runtime associated with this installation configuration process right here in this last command. So the way IPython works, just as a high-level overview to get everyone on the same page, is inside of your terminal, you can just do IPython3 space notebook, and that'll basically generate all of this output here, which you can kind of ignore for the most part, because that'll just have IPython 3 open up a new browser tab here at localhost port 8888. And if you just click on once you clone the repository and move into it, once you click on this IPython notebook here with this file name extension, just exploring natural language processing, you'll be able to do exactly what we're doing here on the screen. So if I do, the way that I'm going to be going through each one of these commands, you can probably look up Jupyter Notebook or IPython 3 hotkeys, but the only combination I'll be really be using is Shift Return or Shift Enter on this computer right here. So if I just do Shift Enter, what you'll see is this little box next to what's called, these are called cells here, and these are just executing individual bits of Python code. If I just do Shift Enter here, and then what happens is this number right here populates, and if I do Shift Enter here where we define the function, the only function in our program to do natural language processing, you'll see the 2 intuitively populate in this box right here. So this is what I would call like the second cell, or cell number 2, and this first cell here with some installation configuration setup stuff in regards to some contact info is what I would call cell 1, just for future reference. So what's going on here is we're just importing NLTK and the regular expressions module. And what's really cool about the Python programming language, in my opinion, is the fact that it's so extensible. You can just write import, say NLTK, a library created and developed and maintained by the University of Pennsylvania, and then say this regular expressions module, which is really just part of the standard library, and that's giving you access to regular expressions. If you don't know what those are, don't worry about it. Basically, what they help you do is parse a bunch of different commands, parse a bunch of different strings, and with what are called regular expressions, which you can do in the terminal with a series of commands, say like something like sed or awk. We won't be going into those because Python provides this really nice interface via its built-in module inside of its library, which we're just importing here. What we're doing next year is defining this function format sentence, which we'll be using in the next 2 cells, and all the way at the end when we're kind of testing, if you will, our actual machine learning algorithm or our classifier, which we're also going to be using from NLTK. So what's really neat is if I come down here and just do Shift Enter, we're just executing the Python that's just encapsulated within this cell. And all that's going on here is we're just opening up a list called pos, for short for positive. And that's just, again, an empty list or just an iterable in Python. And we're just opening and closing actually with the with open statement, this file called positivetweets.txt, which you can see here is one of these components inside the local environment that we're running the IPython Notebook out of, right? So that file looks something like this. It's a bunch of tweets with the actual, the string is actually, it starts with the username, and then it's kind of like something like, say, this says, "You too follow a fellow Lakers fan, beautiful." Or someone else says, "You are very welcome." So these are kind of like, in a sense, positive tweets or tweets that express some positive sentiment. And all we're doing is loading these tweets into memory right now and storing it as this variable f. And then we're just going through that iterable with this sort of with this for loop or some sort of iteration behavior, which you can do in another language, say. And then we're just appending to this empty list every single thing, and we're calling this function here, again, which I was talking about earlier. And that function is really just tokenizing each tweet, or what that really means is it's just taking every single tweet and splitting it up into its individual words, right? So it's just taking in this arbitrary positional argument, and it's passing it to this NLTK .word tokenize method. So what that really means is inside of the NLTK module, there's a subscriptable method, or there's this function that's written inside of there that's just going to do all the heavy lifting of just taking that tweet and just splitting it up into its individual words. And then just like it's going down here, what we're doing is we're really just adding to this list pos. The same thing is going to happen for negative, right? So if we do both of those, by the way, if you're not familiar with Jupyter Notebook, this might seem like a little bit of a weird thing, but basically this, if I just write the variable name pos, which we kind of defined up here and executed in cell number 3, likewise in the following cell with cell the variable we define in cell number 4, if you just type in the variable name and then do Shift Enter or execute the actual cell, it's the equivalent of what I've commented out above, which is this print pos, right? So this is just basically a list of lists with dictionaries inside of them, and each one of those items in the dictionary, or each one of the keys rather, is associated with a value which is true, uniquely, just because these are all inside of say the positive tweets in this sense. And in the next cell, what we're doing is we're just going to print out and check out what's going on inside the negatives, right? This list of lists that all include one dictionary inside of each respective list. The general point is that each one of these items that we're tokenizing is just an individual component of that tweet. So if I come down here now to training, if we just say training equals, and then what we're doing here in this kind of, if you haven't seen it before, in this kind of like tight and a little bit funky syntax is we're just taking effectively 90% of each one of the words in these two files, and we're just storing them inside of the training variable name, right? And we're storing the remainder inside of test. If you're not familiar with this concept of splitting your testing and your training data in machine learning, the general idea is that you're taking your entire data set, or 100% of your data set, and you're splitting it generally into something that might be analogous to a Pareto distribution, like the 80-20 split. The general idea there is that you don't want your model to overfit the data. So even though we're importing our model below with the naive Bayes classifier from the NLTK module, nltk.classify, the thing that we're doing is we're just taking 90% instead of 80%, say in a Pareto distribution, we're taking 90%, which is a little bit more aggressive in regards to the allocation to training, and then we're just testing on this last 10%. So if I execute these two here, you'll see that if I were to just print out training just by typing in the name of the variable here and then executing a cell so the contents are output at the terminal, these are just like the list of lists that we have above, right? And each one of these things is, it says true just because these are components of an individual say text file like positive tweets or negative tweets, but the only thing that's different in regards to training and testing is that, again, training includes the positive tweets and the negative tweets, whereas say positive and negative just included the positive and the negative. So if I say here that, say, inside of the training set, let's look for the word POS with Command F, POS, right? We have pos inside of here, and then if I look for neg inside, sorry, here. So what I'm saying is training includes the positive and the negative tweets. So again, if we go here, right? So these are both inside of positive, inside of training, and likewise with testing. So if I do Shift Enter here, and we look for those, we can see that there's the first tweet happens to be positive, right? So this is kind of like a separate item in the iterable aside from the dictionary object, which is the tokenization of all these words. And then basically if we type in neg, again, and we search inside of testing just manually, right? One of these will actually be eventually down here, neg, right? So all the way down to the bottom here, just because we're just simply just adding the neg after the positive. So that's why it's all the way at the bottom there. So now if I do, we do this naive Bayes classifier, what's really neat is we can actually classify these strings below. So we're just importing from NLTK. Since it's such a large library, we want to reduce the import time, and that's what's going on here. If you're unfamiliar with kind of like this syntax in Python, we're saying, hey, from NLTK and inside the classify module inside NLTK, just give us the naive Bayes classifier, because the two things that we can modify or kind of like improve in regards to the performance of a high-level scripting language like Python is really either the import time or the runtime. So here what we're doing is we're really just trying to improve the performance or shorten the import time. So we're just importing the naive Bayes classifier, and it also kind of saves us some typing downstream. So, and I like to basically kind of quote, I forget who exactly it is, but there's this general notion that programmer time is much more valuable, say, than processor time. So the general idea here is like we just only have to say naive Bayes classifier instead of, say, doing classify.nltk naive Bayes classifier .train, right? So if I execute the cell down here, there isn't any output, but on the next line, or next cell rather, what we have are the most indicative words inside of our data set. So awesome happens to have the ratio of 18.7 to 1 of the time it's positive. Say a little bit further down, or on the next line, we have headache, and that's actually kind of like the complete opposite. We have 18 to 1 in regards to some ratio. It is more often than not negative instead of positive, right? So, and that continues down in regards to informative features, so to speak. And this is, again, something that's exposed, this function right here, by this classification module, the naive Bayes classifier, inside of NLTK, which is just really cool. So if I do Shift-Enter with example 1, this is really just, what's going on here, by the way, is this is just an example of a string. Say this is basically like a sample tweet, if you will. And this is just saying this workshop is awesome. So awesome is actually the most indicative word inside of our training set. So what's really interesting is, like, when we go to basically validate our model, what's interesting is that this this string right here is coming into the format sentence function that we defined earlier, all the way up here. And what that's doing is really just taking this example of a string, or basically this sample tweet, it's passing into that function that I just scrolled up to and we defined earlier. And then it's basically using the classifier and this classify subscriptable method on this particular module that NLTK provides for. And it's saying this example of a tweet is positive. Incredibly enough, if we do another example, which is just the same exact string, except the word awesome is changed to awful, what's interesting is, like, that's our model is actually telling us it's classifying this string as a negative, or a string with some sort of negative sentiment. So what's interesting is, you know, we may follow up on this with something a little bit more nuanced in regards to basically creating a scale of how positive or negative something is. Something like, say, the data that's included here in this output. But say we have this sort of user input from a webinar chat variable name, or I'm just going to call this sample tweet, right? So this past weekend, the Titans played the Chiefs, and I think a lot of people thought that the Chiefs were going to, you know, clean up against the Titans. And interestingly enough, the Titans beat the Chiefs. So this is a little bit more of a complex sentence in some ways, because, you know, it's longer, just kind of, you know, just categorically speaking, and then two, what's interesting is it's just a little bit more of a complex sentence, if you will. So if I do Shift-Enter here, sample tweet, oops. So if you actually, what's cool about IPython is if you actually make that error in regards to, say, not defining something like this tweet right here, you can always, it doesn't basically make you rewrite all this stuff or anything like that, say like in a REPL. You can really just do Shift-Enter in that particular cell. So you'll see 14, and this is the 18th run. So this next one will be 19, this cell. But what's interesting here is that this, I would submit that this is there is a positive sentiment expressed in this sample tweet right here. It's being stored in the sample tweet variable, and that has a positive sentiment associated with it. So if we come down to the very bottom, the last thing that we'll do is just get an idea of how accurate our model is right now. So what we're doing now is we're basically just saying hey, how accurate is this model? And that's, again, nltk.classify.util. We're just importing the accuracy. And what's really interesting is like that it's it's saying that this is generally like 95 or 96% accurate in regards to the testing versus the training outputs. So basically, training being kind of like where all of our data is labeled, but when this model is run, say it is it's about like 95 or 96% accurate. So if you have any questions, feel free to get in contact with me. You can get in contact with me here at this email address. And again, you can download this sample code here at this GitHub profile. If you have any questions in regard to the integration, you can always hit me up again at that email address. And yeah, I'd be happy to see what you guys come up with from tuning in to this webcast, and hopefully we'll follow up with something a little bit more elaborate in the future. So stay tuned, and we will, hopefully be in touch. So thanks for tuning in, and I will end the webinar now. Thanks.